Stay with me until the very end of this video, because what you're about to hear will push your imagination to its limits. Today, we're traveling to a world so extreme, so violently hot, so utterly hostile to everything we understand about planets that it almost shouldn't exist. This is the story of the hottest planet ever discovered, a world where the laws of nature seem to bend, where matter behaves like liquid metal, and where temperatures rise so high they challenge our understanding of physics itself. Imagine a world where the atmosphere glows like a furnace, a world where the sky burns white hot, a world where the ground is so scorching that even rocks would vaporize, a world so close to its star that a single day could melt steel, vaporize oceans, and strip away entire layers of a planet's surface. This isn't science fiction. This is real, and astronomers have seen it. The planet is called Kelt 9b, and it is unlike anything we've ever found. It orbits a star so hot and massive that even the sun looks calm by comparison. Kelt 9b is so close to this star that it completes an entire orbit in just 36 hours. That means a year on this planet is shorter than 2 days on Earth. But the real insanity begins with its temperature. Kelt 9b reaches over 4,300 degrees Celsius, hotter than some stars. Yes, you heard that right. This planet is hotter than actual stars in the universe. And that's just the beginning. Before we dive deeper into this inferno, if you're enjoying this journey so far, make sure to like the video, subscribe, and turn on the notification bell. It helps the channel grow and ensures you never miss another trip into the unknown. Now, let's talk about what makes Kelt 9b so extreme. First, its star. Kelt 9 is a massive blue-white star, burning at nearly 10,000 degrees Celsius. It emits intense ultraviolet radiation, the kind that would destroy DNA, strip atmospheres, and tear apart molecules. And Kelt 9b orbits so close that it's practically skimming the star's surface. The gravitational forces are so intense that the planet is stretched into an egg-like shape. It's literally being pulled apart. But the heat is what makes this world truly insane. At over 4,300 degrees Celsius, the atmosphere becomes a chemical battlefield. Molecules can't survive. They're ripped apart into atoms. Even metals like iron and titanium don't stay solid. They vaporize into gas. Imagine a world where iron floats in the air as vapor, where the atmosphere is a swirling mix of atomic fragments, where the night side is still hotter than a blast furnace. That's Kelt 9b. And because the planet is tidally locked, one side always faces the star. That means one hemisphere is in eternal, blistering daylight, while the other is trapped in permanent night. But don't think the night side is cool. Winds blow at thousands of kilometers per hour, carrying heat across the planet. The night side still reaches temperatures that would melt lead. There is no escape from the heat. Scientists believe that Kelt 9b is slowly evaporating. The star's radiation is blasting away its atmosphere, stripping it layer by layer. A giant tail of gas trails behind the planet, like a comet made of vaporized metal. Over millions of years, Kelt 9b may completely disintegrate, leaving nothing behind but a cloud of atoms drifting through space. It's a planet living on borrowed time. But here's where things get even stranger. Because the planet is so hot, its atmosphere behaves like the atmosphere of a star. Atoms become ionized, electrons break free, the air becomes electrically charged. In some ways, Kelt 9b is more like a failed star than a planet. It sits in a bizarre category of objects that blur the line between planets and stars, a place where the definitions start to break down. Now, let's explore what it would be like to stand on Kelt 9b, not that you ever could. The moment you arrived, you would be vaporized instantly. Your atoms would scatter into the atmosphere. Even a spacecraft made of the strongest materials known to science would melt long before reaching the surface. The radiation alone would tear apart electronics. The heat would destroy everything. There is no scenario where anything survives here. Kelt 9b is the definition of uninhabitable. But that's what makes it so fascinating. It challenges everything we thought we knew about planets. Halfway through this video, I want to remind you to like, subscribe, and hit the bell if you're fascinated by the extremes of our universe. It helps the channel grow and lets me keep bringing you these deep space explorations. For decades, astronomers believed that gas giants couldn't survive near such hot stars. They thought the radiation would destroy them. But Kelt 9b proves that planets can exist in places we once thought impossible. It forces us to rethink how planets form, how they evolve, and how they die. And Kelt 9b isn't alone. There are other ultra-hot Jupiters out there, planets like WASP 121b, where the atmosphere is so hot that water molecules are ripped apart. Or WASP 76b, where iron condenses on the night side and falls as molten metal rain. Yes, you heard that right. On some planets, it rains liquid iron. The universe is far stranger than we ever imagined, but Kelt 9b is still the king of heat. No other planet comes close. It is the hottest planet ever discovered. A world so extreme that it pushes the boundaries of what a planet can be. A world that shouldn't exist, but does. As we approach the end of this video, think about what this means. Our universe is filled with worlds that defy logic, worlds that challenge our understanding, worlds that show us how small and fragile Earth really is. Kelt 9b is a reminder that the cosmos is not just beautiful, it is violent, chaotic, and full of extremes beyond anything we can imagine. As we continue exploring the unimaginable extremes of Kelt 9b, it becomes clear that this planet isn't just an outlier, it's a cosmic warning about how diverse, violent, and unpredictable the universe truly is. When astronomers first detected it, they didn't believe the data. A planet hotter than stars, a world where molecules can't exist, a gas giant being torn apart in real time? It sounded impossible, but the universe doesn't care about our expectations. It simply is what it is, and Kelt 9b is one of its most dramatic reminders. What fascinates scientists most is how this planet challenges the very definition of a planet. Traditionally, planets are cool enough for molecules to form atmospheres to stabilize and chemistry to behave in predictable ways. But Kelt 9b breaks all of that. Its atmosphere is so hot that hydrogen atoms, the simplest atoms in the universe, behave differently. They stretch, collide, and ionize in ways we normally only see in stars. In fact, if Kelt 9b were just a little hotter, it might not be considered a planet at all. It would cross the threshold into the realm of stellar objects. It sits right on the edge of what's physically possible. And then there's the question of how it formed. How does a planet end up so close to such a massive star? Did it form there? Did it migrate inward over millions of years? Or was it captured by the star's gravity long after it formed somewhere else? Each possibility raises new mysteries. If it formed close to the star, how did it survive the violent radiation during its early years? If it migrated inward, what forces pushed it so close without destroying it? And if it was captured, what happened to the rest of the system? Did other planets get flung into space? Did they collide? Did they fall into the star? Kelt 9b forces astronomers to rethink planetary evolution. It shows that planets can survive, at least temporarily, in environments we once thought were instant death zones. It proves that the universe is far more chaotic and experimental than we imagined, and it hints that there may be even stranger worlds out there waiting to be discovered. But perhaps the most mind-bending part of Kelt 9b is what it teaches us about the future of planets. Because one day, billions of years from now, our own sun will expand into a red giant. It will grow hotter, larger, and more violent. Mercury and Venus will be swallowed. Earth will be scorched. Our atmosphere will evaporate. Our oceans will boil. Our planet will become a world of fire, not unlike Kelt 9b, in a strange way. Studying this distant inferno gives us a glimpse into our own distant future. It shows us what happens when a planet gets too close to a star that's too powerful. And yet, even in this chaos, there is beauty. The glowing atmosphere, the shimmering tail of vaporized gas, the dance between a dying planet and a star that burns too brightly. It's a cosmic tragedy, but also a cosmic masterpiece. A reminder that the universe creates wonders not just in calm habitable zones, but in the most extreme, violent corners of existence. As we close this extended journey, imagine looking at Kelt 9b from afar. A glowing ember racing around a star like a spark caught in a hurricane. A world fighting for survival against forces far beyond its control. A planet that shouldn't exist, but does. And in that existence, it tells us something profound. The universe is bigger, stranger, and more unpredictable than we can ever fully understand. Before we wrap up, make sure to like the video, subscribe, and turn on the notification bell so you don't miss the next journey into the unknown. And I want to hear from you. What do you think is stranger? A planet hotter than stars, or a world where it rains molten iron? Let me know in the comments. I read every single one. Thank you for watching until the end. The universe is full of mysteries, and together we're just getting started.